Hey guys, welcome to another video of your favorite cloud learning platform, K21 Academy, where you learn cloud from the experts. In this video, our expert trainer will be covering a few topics, starting with working with Azure SQL Database, working with Azure Synapse Analytics, provision and query data in Azure Synapse Analytics, and in the end, he'll be covering import data into Azure Synapse Analytics using PolyBase. We have taken this clip from our step-by-step learning program on data engineering on Microsoft Azure DP-203. Guys, make sure you watch the entire video so you can avail the free gift at the very end. Now, let's hear from our expert.
Welcome back, guys. Now coming over to model number 5, we'll talk about relational data stores in Azure Cloud, and we are starting with Azure SQL Database, and we'll come to Azure Synapse. We'll see how to provision and query data in Azure Synapse and import data into Azure Synapse using PolyBase. So as part of lesson number 1, we'll talk about Azure SQL Database. And as part of that, we are going to talk about why do we use it, what configuration and pricing options are available, how do we create database from the portal, and how to connect to using Azure Cloud Shell, how do we connect to Azure SQL, and basically run queries over there. So coming to the first section, why Azure SQL is a good choice. Azure SQL is platform as service. We only pay for what we use in the point in time, and databases can be as big as 100 terabytes. It's very convenient to work with Azure SQL. You don't even have to manage the infrastructure over there. When it comes to cost, we have various type of pricing models are there, and Azure SQL can also be serverless, right? So what the meaning of serverless is that compute will be on demand and you are just paying for the storage cost. So normal Azure SQL database is platform as service, but there is a mode available over there now that is called as serverless mode. So the cost even goes down further. It's highly scalable, and whenever the scaling happens, there is no downtime. It's zero downtime. It scales in real time. And when it comes to security, as part of security, we have encryption at rest, encryption in motion, always encryption, and many more things are there by which we can make it more secure. So when it comes to configuration of Azure SQL, basically the first thing is that we have to create a logical server. See, in infrastructure service, there was a VM. Inside the VM, we used to install the databases, right? So that VM thing is not here anymore because it is platform as server, but that VM concept is now logical. So we call that logical server. So it's just like a logical boundary. It's nothing more than that. There is no VM running behind the scenes for your scenario, but you can say there is a logical boundary, and inside the logical boundary, you can have many databases. You can have maybe 5, 10, 20, 100 databases like that. So first thing is we create the logical server. Inside the logical server, we create databases, right? Now, when it comes to pricing, two type of pricing is there: DTU based pricing or virtual core based pricing. You see this DTU and virtual core. So DTU is database transaction unit, or we even call this database throughput unit. Both the words are there, right? Now, DTU is a combination. What does it combine? Just like in the previous section, you have seen Cosmos database had request units, which was a combination of amount of resources. Here also DTU is the amount of resources. So when we talk about DTU actually is a combination of compute, storage, IOPS together. So we assign DTUs to the databases. You might have two databases, A and B. So A database is having 100 DTU. And to the B database, you have assigned 1000 DTU. So the B database is 10 times more performant than the A database. So DTU works like that. Now, if you want more control, you want that, okay, no, we don't want combination of compute, storage, IOPS. We want that I should be in control of my compute and storage should be separate. Meaning compute and storage concept should be separate. They should not be combined together in one number. You should be able to select the compute separately and storage separately. Like combination should be there. Two options are there. Then we go for vCore based pricing. And virtual core based pricing, it gives more control over what compute and storage resources you create and pay for. So vCore model enables you to configure resources independently. That happens. In DTU based pricing, it's like one number. There is no separate selection of storage or compute. You cannot say that I want more compute, less storage, or less storage, more compute. That option is not there. And vCore based, you get those type of functionalities. Okay, now coming over to Azure SQL Elastic Pool. Azure SQL Elastic Pool basically means resource sharing. I'll give you two scenarios. Scenario number one, we have two databases, A and B. And to the A database, we gave 300 DTU. To the B database, we gave 600 DTUs. However, in the second scenario, we created one pool and we gave the elastic DTUs to the pool instead of individual databases. And then we are putting those databases inside the pool. So the pool represent resource sharing over here. Now, when we have many databases over there, maybe 10, 20, 100, 140, even I have worked in scenarios where 140 databases were there in one pool. So overall cost comes down. Why? Because better utilization of resources are going on. The only thing you have to remember is we keep those databases in the pool which do not require same performance at the same time. So this is called as Azure SQL Elastic Pool, and it relates to eDTUs. They enable you to buy a set of compute and storage resources that are shared among all the databases in the pool. Each database can use the resources they require whenever they require, right? So this is called as Elastic Pool. We also have Azure SQL Managed Instances. Azure SQL Managed Instances, they create a database which is 100% compatible with the on-premises Azure SQL on-premise enterprise edition of the database engine. And it is very useful for those customers who want to lift and shift. So if you want to lift and shift and want to go to cloud, you can go to Azure Managed Instances. In Azure Portal, creation of Azure SQL Wizard looks like this. You have to specify the database name and the server name. So this server is a logical server and database will be the database inside the logical server. And then we select the pricing from below over here, and accordingly we create it. So in the lab part, we'll practically do it. And check this out. Right now, let's move ahead and notice this. So how do we connect to the Azure SQL from Cloud Shell, from command line if you want to do that? Basically, the first thing is you need SQL CMD is required. You need to install that SQL CMD, and luckily in Azure Cloud Shell it is already installed, so you don't have to worry about it. So this is how the syntax looks like. The username is here, Martina. Password is that, and contoso-1 is the name of the logical server. So the FQDN looks like this: contoso-1 database.windows.net. So logistic is the name of the database, -d you can see, and username and password. So basically it connects to the cloud. And how do we create table? The table creation is the same old table creation which we do in the SQL world. So create table name, and driver, last name, varchar, first name, origin city, and so on and so forth. Go basically means execute. So like that. And how do we select something? We can say select name from sys tables, or you can insert into drivers as well. So that we are inserting some values: 123, first name, last name, Springfield, origin city. So same structure is there, same syntax is there that we are familiar with from on-premise SQL as well. Now let's go to let's check out some of questions over here. The very first question is, who is responsible for performing software update on Azure SQL database and underlying operating system? I wonder who is responsible for that. It's platform as service, right? So actually we are not responsible for it. So Microsoft Azure, the cloud, manages it. Azure manages the hardware, software update, and the OS patches for us. What is an Azure SQL logical server? Azure SQL logical server is just like a logical boundary, right? And an administrative container for your databases. You can have more than one database over there, and basically we have firewall on the server level, and so on. So many type of concepts are there. So it's a logical boundary where all databases are kept inside. Your Azure SQL database provides adequate storage, compute power, storage and compute power, but you want to find that you need additional IOPS throughput. Which performance model might you use? So we want to basically control, you can say, storage and compute more. We can go for vCore based pricing, where we have more control on the way we are selecting resources. Now coming to lesson number 2. In this lesson, we'll talk about Azure Synapse Analytics. In this lesson, we'll talk about, first of all, what is Synapse, like what is the meaning of it? And then we'll talk about the features, type of solution workloads, what is massive parallel processing engine over there, and we'll talk about table geometry. Table geometry basically means what type of table distribution modes are there. The very first question that should come to your mind is, what is Azure Synapse Analytics? Now, Azure Synapse Analytics is a scalable cloud-based data warehousing solution from Microsoft. It is the next iteration of Azure SQL Data Warehouse. Earlier it was called as Azure SQL Warehouse, and now it has been renamed as Azure Synapse Analytics. So Azure Synapse Analytics it basically provides a unified environment for combining the enterprise data warehouse, big data analytic capabilities of Spark, data integration services, and it makes movement of data between internal and external sources pretty easy. And we can ingest data, prepare, manage, serve data for immediate BI and machine learning requirements more easily with the help of Azure Synapse Analytics. There are various benefits of doing data warehousing with Azure Synapse Analytics. Now, a couple of use cases which comes to my mind will be that we can independently size the compute power irrespective of the storage requirement. We can increase or shrink the compute power without moving the data. Another benefit will be that we can also pause the compute power and we leave the data intact and we only pay for the data. So compute can be paused if not required. And whenever required, we can resume the compute during operational hours. Now, Azure Synapse Analytics is having a couple of additional features as well. One of the features is called as workload management. This capability is used to prioritize the query workload that take place on the server using workload management. Now, there are three components or three sections of workload management. First is called as workload groups. Basically, the meaning of that is that you can create groups and those groups can be associated or resources can be allocated to those groups. So you can reserve the resources for a group of requests. You can limit the amount of resources a group of requests can consume. You can also share the resources accessed based on importance level. Like you can have low importance, below normal, normal, above normal, high importance workload. You can also set the query timeout value. You can say, okay, that after this much amount of time, the query will automatically time out. Now coming over to the workload classification and workload importance. So basically try to think in this manner. I'll give you a couple of examples to explain it. Now, when I think in terms of workload classification, let's say I have data coming from the sales team. So I have one class, sales class. I have one class, marketing class. There is another class, weather class, maybe weather data. Fourth class can be data coming from CEO. So as a data engineer, data coming from the CEO and the queries which the CEO wants to run on that data might be of high importance. So to the class data coming from CEO, we will give workload importance high. And to the class maybe like weather, you might give a importance low to it because those queries might not require that much of, you don't want to give that much of compute, IOPS, memory for it to run in that point in time. So this is the meaning of workload classification. You can create these classes and you can allocate importance to that, like how important is this particular class, and based on that resources are allocated to that particular query while running. Now the next concept is called as result set cache, and when we enable the caching functionalities, basically the queries which are running again and again, the results of that is cached in the SQL pool storage, and those queries do not run again and the values are fetched from the cache. So it's pretty fast when the caching is enabled. Now coming over to the views. Now the first thing you need to understand is view is a virtual table, and we create these logical virtual table with the help of select statements. And there are two types of views which you need to understand. The first is called as standard view. Second is called as materialized view. Standard view compute the data each time when the view is used. There is no data stored on the disk. Versus a standard view, in materialized view, the data is pre-computed. Or I can say a materialized view pre-computes the data and stores and maintains the data in SQL pool just like a table. There is no recomputation which needs to happen when the materialized view is used. Because of these functionalities, the queries which are using the data which is there, either all the data or the subset of the data which is there in materialized view, they are faster because it's already stored in the disk like a table. Another functionality of Synapse is that it supports SQL Server data tools. And these SQL Server data tools, they allow the team of developers to collaborate over a version controlled Azure Synapse Analytics, and they can track and deploy and test the schema changes. So as part of the solution workload, there can be many scenarios where Synapse can be used. Data might be flowing into Synapse from various solutions. It might be coming from transactional system, relational databases, or maybe from other sources on periodic basis. And the data which is stored in the Synapse might be used for historical and trend analysis reporting. Okay, so let's understand the massive parallel processing concept of Synapse. Now remember guys, in Azure Synapse Analytics, there are two concepts. There is a compute node and there is storage node. Storage will always be 60 and compute node can be 1 to 60. And there is on top of the compute node, we have one concept called as control node. So there are three things and two of them are there in the screen. Control, compute and storage. Storage is always 60, compute is 1 to 60 and control node is basically which breaks the query down. So let me give you one scenario. So imagine that there is one Azure Synapse Analytics where we have 60 compute nodes and these 60 compute nodes are sitting on top of 60 storage nodes. So if I run a query, control node will break my query into 60 smaller pieces and these 60 smaller queries will be running in individual compute nodes. So 60 queries on 60 compute nodes are running parallelly, and those 60 compute nodes are pulling the data from storage nodes and they are doing huge transformation in parallel manner. And this entire architecture is called as MPP or massively parallel architecture. And Synapse is pretty powerful when it comes to running queries, transformations on huge amount of data for analytical processing. Now let us understand the table geometries. Now, when we create the tables in Synapse, there are three types of tables you can create. One is called as round robin table. In this, the data is inserted in round robin manner. Second is called as hash distributed table, where we use a hashing function for doing the partitioning and data is inserted based on that hashing column. And the third one is called as replicated table, when that same table is replicated on all the compute nodes. And in replicated table, basically the table size should be less than 2 GB, then only we can use that. So I have two questions over here. The first question basically means that how do we measure or the resources which is allocated to the warehouse? We have a unit called as data warehouse unit which is used. And in the second question which came in the certification, there are 263 stores are there nationwide, and in these stores they retrieve the data from one table. So we want to select which type of table do we have to go for, round robin, hash or replicated table. So just FYI, replicated table actually is used when we have a huge read requirement. So if there are 260 stores which are nationwide and all these stores are retrieving the data from this one particular table, then because of the huge read requirement, the most suitable type of table to be created will be a replicated table. That's the answer for it. Now coming to lesson number 3. In lesson number 3, we talk about how do we create Azure Synapse and how do we query Synapse. So in this lesson, we'll talk about how do we create Azure Synapse, and then we'll talk about some query sample queries as such, and how different type of tools such as SSMS or Power BI can use Azure Synapse. So when we create Azure Synapse Analytics, basically we have to provide the subscription resource group, the name of the Synapse, and the server name. So just like Azure SQL, Azure Synapse also lies inside logical server. You basically have to create the logical server, and it's the same logical server which we have previously talked about in terms of Azure SQL. And in the same logical server, both Synapse and SQL can coexist as well. Here we have some normal queries, and these queries are the same queries which we run against any SQL server. So you can have a look at a couple of the examples over here. Select star from product P, where p.id is equal to 1. So when we create table, you can use create table, table name, and the normal syntax, or you can also create a table using CTAS statement, which is basically create table as select. And one example over here, create table fact internet sales table, the copy table with distribution hash distribution by the column sales order number, and the data will be inserted with the help of select star from fact internet sales. You can use SSMS to connect and query Synapse. Two questions over here. Which port do we use to connect to Azure Server Data Warehouse, Azure SQL Server Data Warehouse? The answer will be 1433. And in the second question, there is a table syntax and the queries are running slow. So what we can do partitioning. And when we talk about partitioning, we can do the hash-based distribution of data or partitioning with the help of hashing column. And that column can be reseller key for both the tables. So the answer will be change the distribution to hash bracket seller key for both the tables. Now coming to lesson number 4. In lesson number 4, we'll talk about PolyBase and how do we load data into Synapse with the help of PolyBase. So in this lesson, we are going to talk about PolyBase, meaning of it, upload data, how do we make the security keys, how do we create Azure Synapse Analytics, and we import data from blob to the data warehouse. The very first question that should come to your mind is like, what is the meaning of PolyBase? Now, PolyBase is an utility by which you can connect the Synapse to external data sources. And when you run the query again in the Synapse, these queries can run against those external data sources as well. So for example, I might be having data in data lake, and that data lake is connected to Synapse, or maybe I have data in storage account, blob storage, and that blob storage is now connected with Synapse. So when I'm running the query in Synapse, even when the data is there in the external or remote data lake or blob, the query can fetch or pull the data from those locations as well. It works because of PolyBase. So PolyBase is that utility which helps us connect those external data sources and run the transact queries against those external data sources as well. In the lab, guys, we'll upload the data into blob storage. And once we have done that, we will copy the keys from it. Then we will create one Azure Synapse Analytics. Now inside Synapse Analytics, we'll create the external data objects. Now these data objects, they basically are like variables, and these variables we have to specify in these variables the location from where we'll be reading the data. So in the lab, we'll read it from data lake. We can also read it from HDFS location, which might be running on some particular IP address. And we also have to specify which type of file are we reading. Is it comma separated file, or is it CSV file, TSV file, and so on and so forth. So that details has to be provided as part of external objects. Now the next thing is we will create one external table. An external table is more like a pointer, and it contains the schema, and the data will be in data lake. When we run any select statement against the external table, data is pulled from the remote data lake or blob storage, and it's represented as part of the query output. So I have two questions over here, and the first question came in the certification as well. So, and it's a pretty simple question. We basically have to divide that by 60. We have already talked about that storage is having 60 storage nodes are there. So keeping that information in mind, let's read the question. Mike is the data engineer for Contoso, and there is a data warehouse called as Crystal. There is a table over there, and there is a file called as supply.txt, which is 1200 MB in size, and it is stored in a blob storage. And Azure Synapse is having data warehouse using 30,000. And how can Mike maximize the performance of data load? So basically what happens when you load the data, which is 1200 MB in size, into Synapse, we already know that there are 60 storage locations. So if the file is 1200 MB in size and there are 60 storage locations, then if we divide 1200 by 60, then in each storage location, 20 MB of file will be available. So that's what the answer is. Split the text file into 60 files of 20 MB each. Now coming to the second question, Mike is a data engineer for Contoso and has a data warehouse created with a database named Crystal. He has created a master key followed by a database scoped credential. What's the next step? So basically this is the sequence in which PolyBase connectivity is done. And this question will make more sense once we have done the lab. So let's go to the lab and we will see this process happen in front of us, and then we can come back and answer it. But just FYI, the answer will be external data source. So when we do the PolyBase connectivity, step number 1 is we create the master key, which is more like just used for the encryption purpose. And then we create the scope credential. Scope credential include the key of the storage account or data lake which we have copied and pasted over there. And after that, we create the external data source. External data source means the location from where we have to pull the data. And after that, we specify what is the file format of the file. And the last thing will be create the external table and then run some query against that. So this is the sequence of PolyBase.
We have put on everything about the certification and a lot more on this 12-week roadmap that we have created for you if you are preparing for Microsoft Azure Data Engineer Certification DP-203. On week number 1, we start with explore, compute and storage options for data engineering workloads. Then on week 2, we cover run interactive queries using Azure Synapse Analytics serverless SQL pools. On week number 3, we cover data exploration and transformation in Azure Databricks. On week number 4, we cover explore, transform and load data into data warehouse using Apache Spark. On week number 5, we cover ingest and load data into data warehouse. On week number 6, we cover transform data with Azure Data Factory or Azure Synapse pipelines. On week number 7, we cover orchestrate data movement and transformation in Azure Synapse pipelines. On week number 8, we cover end-to-end security with Azure Synapse Analytics. On week number 9, we cover support hybrid transactional analytical processing with Azure Synapse Link. On week number 10, we cover real-time stream processing with Stream Analytics. On week number 11, we cover create a stream processing solution with Event Hubs and Azure Databricks. By week 11, we are pretty confident that you are ready for the certification exam. So to top it all off, on week number 12, we help you with some tips and resources for clearing certification and CV preparation, along with some exam questions and interview questions. Guys, this is an excellent training program that we have created specially to meet your needs as you are preparing for the certification exam. If you are interested in this training program, then I would highly recommend you to go and attend our free class on Microsoft Azure Data Engineer Certification. In this free class, we will be covering what is Azure Data Engineer role and exam DP-203, why everyone is working on data currently, important Azure services you should learn, and there is going to be a live demo as well on Azure Synapse Analytics components. To register for this free class, go at K21Academy.com/AzureDE02, then select an event date, your name, your email ID, your phone number, and then click on Yes, Save My Seat. Once you click on this button, you will be redirected to this particular page. That means you have successfully registered for this free class. Now, guys, I'll see you guys directly at the free class.